Hi everyone! Today I want to share with you all a method I've used to tackle my coding interviews that can hopefully help you pass your coding interviews as well. Now, I'm not talking about any specific data structure or algorithm, but rather a framework for approaching interview problems as a whole. So first, I want to talk a little bit about why having a framework is even necessary to begin with. This is how I used to approach coding interviews. I'd first panic, and then pray that I'd seen the exact problem before on LeetCode. If I hadn't seen the exact problem before, I would just try to scrap together a solution as fast as possible, and repeatedly run it on the same test cases to debug it before time was up. Most of the time, I would run out of time or fail to even come up with a solution. But even those few times when I did solve the problem successfully, it felt like a small miracle that I wouldn't be able to repeat in the next round of interviews. However, after using this framework, I've been able to stay calm and collected and break each problem down systematically so that it didn't matter whether I had seen the exact problem before. I was comfortable with thinking on the spot and demonstrating solid problem-solving skills. And even when I failed the interview, I was still confident in my ability to interview as a whole. Okay, so let's go ahead and get started. This method is called the APPLE method. APPLE is an acronym for Ask, Plan, Program, Line-by-Line Run-Through, and Evaluate. Let's go over these steps in a little more detail and see what this approach looks like in action. So the first step is to ask clarifying questions. Specifically, come up with a set of at least 3 test cases with a broad range of inputs and verify their expected output with the interviewer. For example, let's say you've been given this problem: reverse string. Write a function that reverses a string. The input string is given as an array of characters S. The problem also gives an additional restraint by saying that you must do this by modifying the input array in place with O of 1 extra memory. For example, hello reversed is O, L, L, E, H, and Hannah with the first H capitalized, reversed, is Hannah with the last H capitalized. Okay, after reading this problem, I have a couple of clarifying questions I want to ask. The first is, what happens if the input is an empty array? Well, it says on the bottom of the given constraints that the string length must be at least 1. So perhaps another edge case would be, what happens if the string length is exactly 1? What happens if we have an even or an odd number of characters? What happens if the string is already a palindrome, meaning it's spelled the same forwards and backwards? Does capitalization matter? Now, we can naturally roll these questions into corresponding test cases. We can create a test case for a single character as an input, and then take LeetCode's 2 provided examples to test an even and odd number of characters and palindromes. This is a good place to verify with the interviewer. Are these test cases valid? Does the expected output match the problem statement? The next step is to plan. Plan out your approach. It can be very intimidating to think on the spot, so try to recall previous problems and patterns you've seen before. This is also where general data structures and algorithms knowledge comes into play. Now, the problem may not map exactly onto a previous problem you've seen, but reason it out slowly and write out some pseudocode or bullet points for your solution. We may think of the interviewer as someone who is just waiting to catch us in a mistake, but chances are, if they're taking the time to interview you, they're probably secretly rooting for you. If you lay out your plan of action for them, it lets the interviewer steer you in the right direction or point out something you've been missing. Let's look back at the reverse string problem, with hello as our input. Naturally, when we reverse a string in our heads, we first swap the first and last characters, then the second and second to last characters, and then so on and so forth until all the letters have been swapped or we've reached the center character. Well, that looks similar to using a two-pointer approach. In other words, we have to use 2 pointers to track the 2 letters we are currently swapping at any given time. So the steps of our solution are: number 1, store the index of the first and last letter. Number 2, swap those 2 characters. Number 3, increment the first index and decrement the last index. And number 4, continue until the indices are the same or the first index is greater than the last index, which means we've swapped all our letters already. The next P stands for program. This is when you actually code up your solution. Contrary to popular belief, this should actually be pretty easy after you've created a solid plan in the previous step, since here you're just translating your pseudocode or bullet points into proper code syntax. For example, let's take the plan we've created in our planning step. We can see that the code just naturally flows from the steps we've laid out. Number 1, set the left index to 0 and set the right index to the length of the string -1. The -1 is there since arrays and strings in Python are 0 indexed. Number 2, swap those 2 characters. Number 3, increment the left index and decrement the right index. And number 4, terminate the while loop when the left index is no longer smaller than the right index. So if there's an odd number of characters, the left and right characters will stop swapping when the left index is equal to the right index. And if there's an even number of characters, the left and right characters will stop swapping when the left index is greater than the right index. Moving on to the L. The L stands for a line-by-line run-through of your solution with one of your earlier test cases. Only by running through your code aloud with an actual test case can you verify your logic is sound and catch bugs early on. Don't just perform a perfunctory sweep over the code with your eyes. Actually write out all the states of all the variables until you've converted your input into your expected output. Let's use hello as an example. The left index starts off as 0, and the right index starts off as 4. We swap the characters at those indices, so we swap the H and the O, and then we increment the left index to 1 and decrement the right index to 3. Then we swap the E with the L, since those correspond with indices 1 and 3. And then both the left and right indices are 2. Then we terminate out of our while loop and return the string O, L, L, E, H. So we verified that our first test case works, and nothing changes if the input is a single letter or a palindrome. So our other test cases pass too. What if our input was an empty array? I know that we had mentioned that the problem said the array must have at least one character in it. But let's just ask if our solution would change if the function could accept arrays with no characters in it. And after looking through it, we would find that it actually would. We can't index into an empty array, so we would error when trying to swap letters. If we wanted to accommodate empty arrays, we'd have to add an if condition at the beginning before we enter the while loop. This is why it's so important to ask those clarifying questions in the beginning, so that we don't end up misunderstanding the question, and, in this case, writing this extraneous if condition if it is not needed. Finally, the E stands for evaluate. Evaluate the time and space complexity of your solution using Big O analysis. Talk about some improvements you'd make if you had more time, and discuss some time and space trade-offs of other potential solutions that you didn't implement this time. For our problem, if n is the length of the input array S, then the time complexity is O of n, or linear, because we are touching each character once when swapping it. And the space complexity is O of 1, or constant, since we are only storing 2 indices at a time. Another thing we could recognize at this time is that instead of using a two-pointer approach, we could have solved the problem recursively by creating a helper function that reverses an array starting from the left index and ending at the right index. Each recursive step would swap a single pair of letters and then recurse on the incremented left index and decremented right index. Alright, that's it for the Apple method. Hopefully this breakdown was helpful for you. Some additional notes to mention is that it's really important to use this method when practicing on LeetCode, not just when interviewing. It can be really tempting to just kind of skip over all these steps and jump straight to the solution when just practicing by yourself. But going through these steps and vocalizing your thoughts is a skill that you should practice. Also, this approach saves you time up front by clarifying the prompt and coming up with a solid plan before coding. The next note is to only run your code on all the test cases when you are confident that it works. Sometimes it's inevitable to have to run your code several times to debug. But try to prevent this as much as possible by running through your code aloud with a test case beforehand. This will build confidence in your solution and demonstrate to the interviewer that you are methodical in your problem-solving approach. Alright, that's it for this video, in which I shared the way I approached my technical interviews. Hopefully it was helpful for you, and good luck in your interviews!